Hi everyone. So today we are going to solve the second problem of variable size sliding window. So remember we are doing sliding window and particularly variable size sliding window. We have already solved one question of it and this is the second question we are going to solve. Minimum size subarray sum. So this is the problem and you can read this problem. I'm going to explain what problem says. Okay, so we have given an array and a target. What we have to do, we have to uh, find a subarray, its length, find the all the subarrays and who's satisfying this condition. What is the condition? This is the sum is greater than or equal to target. Okay, this condition should satisfy. And what is the sum? The sum is the subarray you are considered sum. This is subarray sum. Okay, so what we have to do is we have to find the subarray sum who's greater than or equal to target, but we have to find the minimum length of a subarray. There are a lot of subarrays who going to satisfy this condition. That means a subarray sum is greater than target, but we have to find the minimum length of the subarray who is going to satisfy this condition. For this example, as you can see, 2. That means there is a subarray whose length is 2 that satisfies this condition. That means whose subarray sum is going to greater than or equal to target. And if you see, like, this is the thing, this is the subarray you are, the answer is 4 plus 3 is greater than or equal to 7. That is satisfying, and this is the minimum length. If you find uh, more minimum, like it has a length 2, but if you you are not able to find the answer which is less than 2. So this is the answer for this particular test case. Okay, so brute force approach. What is the brute force approach? Brute force approach is that generate all the subarray and try to find out all the subarray sum, and with that minimize the length. Like you just start with this and go for subarray like this, increase, increase and increase all the subarrays you have to find starting with this index. Then you do the same thing for the first index, like this is the starting one. Find all the subarrays, subarrays, subarrays and subarrays, and you have to do the for same thing for all the index. Try to find the sum, and if that condition is satisfied, that means the subarray sum is greater than or equal to target, then you have to just minimize the length of a subarray. Just do uh, declare a answer, initialize a answer, and then you have to do minimize. So minimum of answer and the length of a subarray, length of subarray that satisfy this condition. Okay, if any subarray which is not satisfying that condition, then we won't consider that uh, that subarray. Okay, so this is the brute force approach. I'm not going to write the code because it's very fairly simple. So the time complexity it would take would be big O of n square, because you are going to use two loops for that, and the space complexity would be big O of 1 constant. So that's it. Can be optimized? Yes, that's why we are here. So we gonna try how we are going to optimize this. Okay, so this is the thing we have given. Okay, so this is the question, and in variable size window, in a variable size sliding window, you have to consider a small window. Okay, very small window, and the very small window is this. Okay, it has the right pointer, left pointer, and the right pointer. Okay, how do we represent the window? It's like a window. The first element is representing the left pointer and the last element is representing the right pointer. Initially, both the pointer is pointing to the same element. Okay, this is the very small window we have to create, and for every this type of problem, this type of category problem, what we have to do, we just create a small window, and according to question, either we grow the window or we can shrink the window. It depends on the questions. Okay, the what problem ask, it depends when we should increase, when we should grow the window, or when we should shrink the window. Okay, in this case, we have to maintain a sum, the current sum you can say. So sum, initially it is 0, and the current window we have this, so we have to do plus 2 and you'll get 2. Now as you can see, my sum, is this satisfying? Is this satisfying? No, it's not satisfying. So we can't include this into our answer. This window is not satisfying. So what we have to do? We want greater. So we have to add some numbers to achieve this. Like we want a bigger number. So we have to add some numbers. Okay. So we have to grow the window. Grow the window. So how we are going to grow window? Let me erase, and my current sum, I'm going to write the current sum only. So the current sum would be 2. Okay. Now grow the window. How we are going to grow? We increase my right pointer. Okay. So increase the right pointer, and my right pointer is pointing to this now. This, and my current window is look like this. My current window is this. Okay. And you have added this into a window, so we have to add this element to our current sum. So it would be 2 plus 3, you'll get 5. Now compare it this with this condition. It is this matching condition. Let's see. 5 is greater than or equal to target. Target is 7. No, this is not satisfying. For what we have to do for satisfying, we have to add some more elements. So we have to grow the window. So for that, what we have to do, let me erase this thing, we have to increase the pointer. So my right pointer is now pointing to index 2, and index 2 is included in our window. So our window looks like this. Okay, the left is pointing to the very first element of window, and right pointer is pointing to the very last element of the window. Okay, now my window is look like this, and I have to add. So let me erase this. My current sum would be 5. My current sum is 5, and I have added one more element, that is 1, and it becomes 6. Now you have to check this condition. So sum is 6 and it is greater than or equal to target. Is this? No. This is again no. So what we have to do? We have to add more elements. Adding more elements means grow the window, increase the right pointer. So increase the right pointer. Let me raise. Increasing right pointer. Now my right pointer is pointing to index 3. Okay. So I have increased my window, and my window look like this. Okay. And we have to add this too. So my sum will become, previously it's 6. 6 plus 2, it would be 8. Okay. Now I have to check this condition. 8 plus, sorry, check condition. Okay, 8 is, my 8 is greater than or equal to 7, which is target. Yes, this is satisfying. This is satisfying means this is, this subarray can be our answer. This subarray can be our answer. Okay, so we have to initialize our answer. So this is the initial value I am going to put over here, which is plus infinity, very maximum, very large number you can put inside the answer. So we have to minimize that. So answer equal to minimum of answer itself and the current length of the subarray, because it is satisfying. This is satisfying. That can be or subarray, that can be answer. Okay, so we have to take the length of the subarray. What is the length? We can generate by r plus l, which is pointer, which is pointing to index. R minus l, sorry, it would be minus r minus l plus 1. This is the length of this window. So what is the length? It would be answer is min of answer, and what is the length? Is 4. So previously answer is infinity, and taking minimum would be answer is going to be 4. So let's just erase this to 4. Now the answer would be 4. Okay, let me erase all this. Okay, after doing this, this condition is satisfying. Okay, but we have to find the minimum window. So if this condition is satisfying, then we will decrease our window, we will shrink the window. How we are going to shrink? Just move the left pointer to the right side. Moving left pointer means my left pointer is now pointing to the index 1. Okay, let me erase. Now my window look like this. Now my window is this, and I have eliminated this index, so I have to decrease the sum, current sum. Decreasing current sum means my previous sum is 8. Let me write it. My previous sum is 8. Now I have to decrease the 0th index. It would be 2 and it would become 6. Now I compare this with this condition. Okay, let me erase. So 6 is greater than or equal to target? No, this is not satisfying. That means what we have to do? We have to grow the window. Growing window means we have to increase the pointer. Now my right pointer is pointing to the index 4 and my window look like this. My window is now this. Okay, I have to add this fourth index value to the answer, to the current sum. So it would become 6 plus 4, this is 10, and this representing the subarray sum of current window. Okay, now I have to compare this. 10 is greater than or equal to target, that means 7. Yes, it is. So what this tells? This tells means my current window can be answer. So I have to minimize my answer. So it would be answer equal to minimum of answer, comma, what is the length of the current window? It would be r minus l plus 1. So my answer would be answer minimum of what is the current answer have? It is 4. And what is the length of current window? It is also 4. So the answer would have 4. So it is 4. So we don't do anything. Let's just erase this. Okay. After doing this, this is satisfying the condition. What we have to find? Minimum subarray. So I'm going to shrink. Okay, shrinking means we have to move the left pointer to the right side. Now my left pointer is pointing to index 2 and my window look like this now. Okay, so my window is this. Okay, I have eliminated the index 1. So what we have to do, we have to subtract that value from the current sum. So it would be, let me erase, the current previous sum would be 10 and I have to subtract 3 and it would become 7. Now we have to compare this with target. So it would be 7 is greater than or equal to 7. Yes, this is satisfying the condition. If it is satisfying, then I have to minimize my answer. So answer equal to minimum of answer and the current length of the window. It would be r minus l, r minus l plus 1. So minimum of answer is what, 4, and the current length, window length, what is it, is 3. So minimum is 3, sorry, this is 3. Okay, now my answer has a new value which is 3. So I'm going to cut this and my answer has a new value is 3. Okay, erase this, and the condition is satisfying. That means 7 is greater than or equal to 7. That means we have to find minimum. So we have to we have to increase the left pointer. That means we have to decrease the window size. So my left pointer is now pointing to index 3. So my current window looks like this. My current window is this, and I have eliminated index 2 value, so I have to subtract that value from the window or from the sum. So it would be 7 minus sum equal to 7 minus 1, it would be 6. Now I have to compare this with target. Okay, 6 is greater than or equal to 7. No, this is not satisfying. That means we have to add some extra value to achieve greater than or equal to 7. So how we are going to add? We have to just increase the window. Increasing window means we have to increase the right pointer, and the right pointer is now pointing to index 5, and we have to just, and my new window look like this. Okay, so we have to add indexed 5 value into the sum. The sum will become 6 plus 6 plus 3, 9. Okay, now we have to compare this sum with the target, and the target is 9 is greater than or equal to 7. Yes, it is. So the current window is satisfying the condition. That means this can be your answer. So I have to minimize my answer. Answer equal to min of answer comma, what is the length of current window? It would be r minus l plus 1. So minimum of, what is my current answer? It would be 3. And what is the length of the current window? It is 3. So this is again 3. So it would be same. So we don't change it. Okay. Now this is, the current window is satisfying the condition. That means we have to shrink the window to get the minimum subarray that satisfy the condition. So how do we shrink? We just increase the left pointer, and now my window looks like this, and we have eliminated this index 3 value, so we have to subtract that value from the sum. Okay, the sum now looks like 9 minus 2, and 9 minus 2, what would be the 7. Okay, now we have to compare this 7 with the target. So the 7 is greater than or equal to 7. Yes, it is. Thus, this window is satisfying the condition. So this can be our answer, and we have to minimize our answer. So how do we? Answer equal to min of my answer, current answer, with the length of the current window. What is the length? R minus L plus 1. Okay. So minimum of 3 comma, what is the length, current length? It would be 2. So the new answer I have did, so I have to update my answer to 2. Okay, let me erase. Okay, the current subarray window is satisfying. Okay, this is satisfying. That means we have to find the minimum subarray. So I will just decrease my window. Okay, how do we achieve this? I will just increase my left pointer. So left pointer is now pointing to the index 5. Okay, so my new window looks like this. Now my new window is this, and I have eliminated the index 4 value, so I have to do this. The sum is 7, so I have to subtract minus 4, and the sum will become is 3. Okay, I have to compare this 3 with the target. Now 3 is this. 3 is greater than target 7. No, it is not satisfying. What we have to do? We have to increase the window, and for that what we have to do is just increase the right pointer. My left pointer is pointing to this, and my right pointer is now pointing to this, and as you can see, there is no element present. We have exceeded the length of the array, so we will stop here, and my the answer is 2. So this is our answer, and this is what we are going to return. Okay, so we are just going to write the code. So we need two pointer. Let's just write a function. Okay, it has a vector nums and a target. Okay, first of all, we need two pointer, a left and the right. Both are pointing to the 0th index because we have to start from the very small window. Okay, now we have to go until my right is less than n. Okay, because right is always higher than the left. Left is always behind the right. It never cross the right pointer. It left pointer never cross the right pointer, so right will reach the end first. Okay, so we have to do this, we have to do check for the right pointer. Why not left? Left is always behind the right. Okay, after doing this, we also need a variable called sum. Okay, so we have to compare while my sum plus the new element. What is the new element? It would be right one. So it would be uh, nums of right are, if it is greater than or equal to target. If my this condition is satisfied, what we have to do? We have to do shrink. We have to shrink the window. Shrink the window. For that, what we have to do? We first of all, we have to, if my condition is satisfied, we have to minimize our answer. So it would be min of answer and the length of the current subarray, a current window, or you can say r minus l plus 1. This is, and what else we have to do? We have to minimize. So minimize means we have to decrease the value from the sum. It would be nums of left. We have to increase the left pointer. It would be l plus plus. Okay, until my the condition is satisfied, we have to do this. We have to do this all the thing. Okay, after the condition is wrong, that means if my condition is fail, what we have to do? We have to increase the window, and for that we have to increase my right pointer. So right, for increasing right pointer would be r plus plus. Okay, After that, we will get an answer. So we have to return answer. Okay, this is the code, a simple code looks like, and answer is initially minus infinity. And in C++, you can use like uh, 1e9. It's a very huge number. You can use it. Not minus infinity, plus infinity. Sorry, it's my fault because we have to take minimum. So initially we have to uh, give a very large number plus 1e9. It's like 1 0 0 0 0 0 and 9. Okay, so this is the way we are going to solve. Let's write the code on a lead code platform and let's try to submit. Before writing the code, let's discuss the what is the time complexity. Time complexity, it would be the right pointer is going till the end, so we have to do, we are going to one loop, so big O of n, and the space complexity would be again constant. We are not using any kind of space, so it is a constant. So let's try to do that in a code. Okay, so first of all, we have to take create a variable that is going to be store the size of array. Okay, we need a left pointer which is the pointing to the first index, and the right pointer is pointing to the again the first element of the array, because we will start with very small window. Okay, and answer variable, initially it has a size, it has a value 29, and while my right is less than n, we have to do this. While my sum, we also need a variable called sum, and initially it has a value 0. If my sum plus nums of right pointer is greater than or equal to target, this is satisfying the condition, so we have to minimize our answer with r minus l plus 1, and we have to subtract the value nums of left pointer, and we have to increase the left pointer. Okay, after, if this condition is not satisfying, that means we have to do, we have to increase the pointer, increase the window, sorry, increasing window. After doing this, and we have to compare if my answer is equal to 1 in 9, that shows there is no subarray present, that sum is greater than or equal to target. So let's just write for this condition. This is the edge case we have to check, because it is mentioned if there is no subarray that satisfy the condition, we have to return 0. So uh, for that, just write it. Okay, if my subarray, there is no subarray, if there is no subarray, sum is greater than or equal to target, so we have to return this answer never update. Okay, that means we are going to return 0, and if this is not, then answer I am going to return. Let's just run this. Okay, I'm getting wrong answer. We are doing something wrong. Let's see what is it. Okay, R is pointing to the initial. Okay, let's do dry run. 1e9, yes. R is less than n. Okay, if my sum plus nums of r, my right pointer, if I add this, if it is greater than the target, okay, r minus l plus 1, answer is going to be this. Okay, I have to do nums minus, if sum is okay, l plus plus, r plus plus. Yes, it is correct. What we are doing wrong here? Let's see. Output is coming to 0 and expected to be 2. Why 0? Uh, Answer won't change. Yes, I think Okay, so we have to add the sum as well, na? Sum plus or equal to uh, nums of r. So we have to do this as well. Okay, so that's why. As you can see, the test case it passed. Let me submit this, and this is accepted. Okay, you can analyze the complexity as well. Uh, it would be big O of n. It's taking time, so okay, this is big O of n, and yeah, one video is uploading over here. So okay, we have done this, and what we have learned from this, again the same thing, window shrink. Okay, so one second, window shrink and grow according to according to problem. Okay, the concept we have learned from this problem. Okay, so now uh, we are going to solve this problem, subarray product less than k, in the next video. So we will see you, I will see you in the next video. Thank you for watching.